In this video, I am going to be walking you guys through an issue that I had on an AGZ chiller. The machine was tripping out on low pressure, and it was also tripping out on no evap flow. A little bit of a backstory on it. They've had a couple other technicians out there, and they've changed the flow switch 3 times on the machine, and they can't get it to stop tripping on flow because the flow switch wasn't actually the problem. And I'm going to be walking you guys through the process I use for troubleshooting the real problem and kind of show you guys the process I use for diagnosing any problem on any machine. So to start off, the first thing that I did when I got to the job was take a look at the alarm menu. So when I'm looking in the alarm menu, I am looking for repeat problems. I'm looking for the date and time that the alarms are occurring to be consistent or repeatable. I'm looking to see if there's a pattern. So this case, there was no pattern. It was completely random. But if it were to have a pattern, say that this chiller was tripping out every single day at 5 p.m. or 6 a.m. If that were the case, then I'd be looking into a scheduling issue. I'd be looking into what happens when the machine goes into occupied mode and what happens when it goes into unoccupied mode. And I'd be using the automation system to force the machine into occupied and force the machine into unoccupied to see what happens and see what conditions happen, see if I could get it to recreate the same condition that is taking place at 4 o'clock, 5 o'clock if it were a repeatable problem. But this is not a repeatable problem. So after I check the alarms, next I'm moving into the sensors and transducers. It maybe sounds like a needless step, but this is something that I do on every single service call. If I walk up to a machine and I'm going to be working on it and there's a potential that I'm going to be using the sensors and transducers to take readings, I need to make sure that they're accurate. And I typically do this right away, especially if a machine is tripping out on high head pressure, low suction pressure. I've done this right away and found that there's bad transducers, and that's why it's tripping on low suction pressure. But you're going to find lots and lots of problems if you just follow a consistent process of troubleshooting things. So since this is a service call, I'm not going to be spending hours on this. I'm not going to be dipping all the sensors in ice water. But what I will do is take all the sensors out, dangle them in the air. As long as it's in the shade, you don't have anything coming into contact with the sun. I'll let them sit there for 5 minutes or so and make sure all the sensors are at least a little bit close. They don't have to be 100% perfect. We're just looking for something that's dramatically different, because in a little bit we're going to be taking readings and we want to make sure our readings are fairly accurate if we're going to be trying to accurately diagnose the machine. So after you check your sensors, then go ahead and do the same with your transducer. Just gauge up to it with your gauge. It doesn't have to be perfect, like I said. Just make sure it's within a couple PSI, just so that way you can trust the readings that you're going to be getting on the Microtech when you are troubleshooting. After I checked all my transducers and my temp sensors, now I'm going to be moving on to putting a water side gauge on the machine so I can check the flow going through the evaporator. In this machine, it's actually quite nice. There is a flow curve inside of the manual for this machine. So what I'm going to do is I'll hook one common gauge up to the machine if possible. If you don't have the hardware for it, just move it from your entering water side to your leaving water side and check your pressure drop. So I checked my pressure drop under normal operating conditions, and we're above the minimum flow for the machine. So everything looks good there during normal operation. So now what I'm going to do is I'm going to calibrate the flow switch. So this uses a thermal dispersion flow switch, and in order to calibrate it, essentially all you need to do is take your pressure drop, look in your book, find the minimum flow rate, valve off the machine until you get the flow through the chiller equal to the minimum flow that the machine is designed for. So once you do that, then you go in and you just calibrate the flow switch based off of that minimum flow, and your flow switch is accurate from this point on. For me, the flow switch was out of calibration, but it's also tripping on low suction pressure. So that tells me that we probably do have a flow problem. And so I'm going to dig a little bit deeper into this because I'm kind of paranoid and I don't like walking away from stuff and having callbacks. So after this point, now we know my transducers are accurate. I know my flow switch is accurate. I know that we have more than minimum flow going through the machine right now in its current operation. So this machine is also equipped with a bypass valve. So next, what I'm going to try to do is use the automation system to force the chiller into 100% bypass mode to test the flow through the bypass valve and to essentially make sure that we're still making flow through the machine when the system's bypass valve opens. So use the automation system, shut down the air handler, close off the air handler valve, the differential pressure rises in the loop, and the bypass valve opens. It opened to 100%, boom, lost flow. We didn't trip on low suction pressure, but we lost flow. So with the machine still off, I went out to the chiller again, checked my pressure drop again, and I saw, oh, okay, now I have no flow or very little flow. Like not measurable. I couldn't measure it with a gauge, my pressure drop anymore. So now I need to find the bypass valve because something's going on with the bypass valve. There's an issue there. The bypass valve is not passing enough flow and the machine's tripping out. So I go and I find the bypass valve, and what I found was the bypass valve was a little 3/4 inch Belimo valve that was bushed up to the 4-inch chill water line. So when I walked in there, the thing was just screaming, and we had no flow through the machine because the bypass valve was dramatically undersized for the system. And again, I am 99% sure at this point, but I'm going to just double check the flow curve just to be sure, because some customers are finicky and some customers don't like to accept that something has an inherent problem. So the same thing with the bypass valve, or same thing with any valve or anything that flows water, there's a flow curve for it. So if you look in the Belimo literature, you can look up the CV rating for the valve, you can look at the pressure drop across the system, and you can determine what the flow rate is through the valve. And I can't remember the exact flow rate through the valve, but I know it was like way less than the flow that we actually need to keep the chiller online with all the pressure drop across the piping and other components in the system. The real problem here was the bypass valve. The bypass valve was dramatically undersized. It's actually quite common. There's issues with the bypass. So sometimes it is undersized, sometimes the timing is off. So maybe they'll have a quick response valve for the air handler, so the air handler will shut down immediately, but the bypass valve takes 90 seconds or 120 seconds to fully open, and before the bypass valve will fully open, the machine will shut down or it'll lose flow. So sometimes you might have to adjust the timing in the automation system in order to get this to work properly, in order to get your machine to not trip on flow. But it is quite a common problem, especially on newer startups and newer machines. So obviously you can't just walk away from it right this second and call it good, call it a day. So you're going to need to order a correctly sized bypass valve for the application. But while you're waiting for that, typically what you can do is set up the system so that way the air handler valve won't fully close down in the short term until you guys can get the new valve installed. So I can't remember exactly what we set it up for, but say the air handler valve you have to set for a minimum position of 50% or something like that in the short term to keep the machine offline. Or if the air handler is going to shut down, then you're going to have to disable the chiller from the automation system until they can get that new valve installed. So now that the machine's been offline, while I've been checking out the bypass valve, the loop has gotten warm. And so before I leave, I'm going to go outside and load the machine up, start it up, watch it run, and then check my refrigerant charge while I'm there. So I've also found other problems like this too, where there's multiple issues happening in the system. So since you're there, the loop is hot, all your sensors are calibrated, all your transducers are calibrated, you might as well check the refrigerant charge while you're there. That way you don't go back, put in your bypass valve, leave the job, and then in July, you find out that the thing's low on charge also, that you overlooked, that you didn't look at. So it takes you an extra 10 minutes now because the loop is hot, everything's already calibrated, and you can just go ahead and check your charge while you're there. Because we took a systematic approach to troubleshooting this, we essentially looked at everything in the entire system, and the entire service call only took, an hour and a half. That's why it's very important to develop your own system of troubleshooting and working through problems, so that way you can look at the entire system, and you can look at the entire system in a very short period of time. But you just need to develop the efficiency behind it. It doesn't make you some rock star super HVAC technician. You just became very efficient at diagnosing problems, and you can find really unique, crazy problems in a very short period of time if you just develop a system of doing things. If you guys found this video helpful, please like and subscribe so we can keep making more like it.